So what we get is 77 I1 negative 3 I2 is equal to 0. This is for our first loop. Let me check first. Alright, and then we will be moving on to the second loop in this part. Let's say we start at point D, moving along in a clockwise manner. We meet R4. So the potential difference across resistor 4 is positive 3 I2. Then we meet the battery, negative 20, because we meet the negative terminal of the battery. We move along the wire and then we meet the positive section of the resistor R5. So we need to put positive sign. R5 is 8 ohm, so 8 I3. So instead of writing I3 here, why not we put I3 is equal to I1 plus I2. So instead of writing I3, we can write I1 plus I2. And then we meet the battery, so plus 6 voltage. Move along the wire and then we stop at this section, right? So we need to simplify this expression or expand this part. We got 8 I1 plus 8 I2, and let's simplify this whole expression. We will get about when we add these two numbers, we will get negative 14. So when we move this negative 14 to the opposite side, we got positive 14. Alright, now this is the physics part of this question. We need to form the expression based on the physics law. So next is we need to use our mathematical skill to solve for this expression to find the I1 and I2 including I3. So for this part, I don't have to show the simultaneous equation. We can use a calculator instead. So click mode, I think 3 times, 1, 2, 3, and then select equation, and then click unknown 2. So here we need to arrange this I1, I2 based on their own coefficient. So if the first part is I1, the second expression, the first initial expression, the first part must also I1 too. So I1 for the first loop is 27 minus 3 equal to 0. So C1 is 0. For second part, A2 is equal to 8 I1. B2 is equal to 11 I2, and C2 is equal to 14. So here we can say that I1 is equal to 0.1308 ampere, I2 is equal to this Y correspond to this number 1.1775, 6 ampere. Okay, that's it. And then we have these two values. So initially we have formed this expression I1 plus I2 is equal to I3. So I3 must be I1 plus I2, which correspond to 0.1308 plus 1.776 is equal to did I add it correctly? So I forgot the one. So for I3 we got 1.3084 ampere. So this is how we can solve the expression. I think I stopped the video until there. So that's how we can determine the current in I1, I2 and I3. So in the next video I will show you how can we determine the current if the question did not give us where the current is flowing. So if you have any question, don't hesitate to contact me. I will try my best to answer your question. And thank you for watching this video and have a great day.